Without further ado, I'd like to introduce a special guest, Michael Abdesaler.
Good afternoon. Thank you very much for this kind introduction. So I wanted to discuss with you something very simple today. It's called the Seebeck Effect. The Seebeck Effect has been around for a very long time. It's very simple. Basically, two materials join together. If you cool one side and you heat the other side, any temperature differential will result into a current. And this is what's called a thermoelectric device. So imagine a panel, not a solar panel, just panel that you can install in an area that's gloomy, no sun. It's very cold. You don't get sun anywhere, and you still benefit from harvesting the energy differential from fluctuating temperatures. And you still generate energy even during the nighttime. Is this new? No, it's been around for a very long time. Nobody was able to use thermoelectric devices on an industrial scale because usually they have two limitations. The first limitation is that they use solder. Solder is a very low melting alloy that is used, and once exposed to a high temperature, anything beyond 200 Celsius, the module just disintegrates. The other limitation is that these semiconductor materials that's used inside the thermoelectric devices are produced using a powder metallurgy process. The powder metallurgy process, we start with metal powders, then we squeeze them really hard together until we have the final shape. Just like your aspirin pill. It is a powder form. It has this solid form because we compressed it together. But once you consume it, it dissolves, right? So it's the same thing. This is how current thermoelectric devices are manufactured. We start with metal powder, compress it, and put them inside these devices here. The problem with that is that once it goes through heat cycles from hot to cold, from cold to hot, it starts to form these micro cracks and disintegrates. That's why, even though that it is a well-known effect, the Seebeck effect, nobody really considered it seriously for any industrial or automotive installation. Today, I am here to let you know that this has changed. So yesterday, our wonderful attorney filed our patent. And I have this small demo unit. I know it's a bit ugly, but I kept it exposed. So for those of us who are technically inclined can see all the components, and you can see that it doesn't have a hidden battery or anything. You can examine it. I have a multimeter if anybody is interested. But this small module here is good enough to charge your iPhone. And what it is basically is two surfaces. If one surface is exposed to the weather elements, that's good enough to generate electricity. Now, am I suggesting that this will replace solar? No, this will complement solar. And installation sites where solar does not make that much economic sense, when it's combined with thermoelectric and you have the ability to generate electricity even during the nighttime, this will enable you to reduce the amount of energy storage devices you need. You don't need that many batteries. So if you're installing solar in an off-grid situation, the major component you have is batteries. How much energy can you store for nighttime, right? But if solar is combined with thermoelectric, then you can cut down drastically. I'm not saying we will eliminate energy storage. We will still need batteries, but not as nearly as many as we need just with solar. And this is the first application. The second application is automotive. As I explained, I come from an automotive background. So we build factories right now for General Motors. And we combine battery cells together into larger modules to be installed in EVs. And one thing I learned that if you introduce anything disruptive to a production line, to an existing production line that's cost like $200 million, is doomed to failure. So even if it's a good idea, and you're asking somebody to change their $200 million plant, it's not gonna work. So what I did is that we filed a patent for two configurations. This flat configuration here, and the other configuration is a pipe configuration. The pipe configuration, basically, once you pass hot fluid inside while you're cooling the outside, it will generate electricity. How can this help with internal combustion engines? And by the way, internal combustion engines are gonna stay with us for a little while until we all transition to EVs. So until this happens, there's no harm with increasing the efficiency of internal combustion engines. So the pipe configuration, actually, you can make a radiator out of it. You get all your hot fluid from your car. You could just retrofit it. Doesn't have to be a new production or anything. Existing vehicles can use new thermoelectric radiators, and it will generate electricity just by the heat differential of the hot liquid going through your radiator and the air that's cooling it from outside. What can this do? This can make your alternator obsolete. You don't need an alternator anymore. You can use the energy that's coming out of your radiator to power all your onboard accessories, like your AC, your radio, everything. And this will raise the efficiency of your vehicle totally. So right now, peak efficiency for a brand new vehicle, anywhere between 30% and 35%. With this device, theoretically, we can raise it 12% more, but I would stick with 6 to 8, just to be on the safe side. The other application we're looking at is greenhouses and commercial properties. Waste heat coming out of factories, we can recoup some of that. Of course, we cannot recoup everything. We cannot recoup all the waste heat that's coming out of factories. But if we can recoup some of that, a lot of factories would love to utilize that to recoup some of this energy and get tax credit for it. It doesn't have to be water. It could be sewer. It could be oil. Anything below 100 Celsius is considered waste heat. And this level of grade of waste heat is perfect for these devices. So some of you will say that maybe familiar with thermoelectric devices. They've been around for a very long time. None of them is suited for long-term commercial application that can withstand high heat. Because I don't have any solder here, this device can withstand 600 centigrades. So this can take the exhaust from your car and will generate electricity if there is a heat differential without any components failing it. I tested it for a very long time. The way we avoid the solder part and we keep components together is that we have perfected a manufacturing method called the capillary casting. And the way we do that is that these PN junctions are joined together like puzzle pieces. So they are mechanically bonded without the need for any low melting solder. The other advantage to this, and what makes it stand out compared to any commercially available product, is that we don't use metallurgy, but we don't use metal powders. We actually cast the part from molten alloys. This gives it a much higher level of rigidity. It mixes the alloys much better. So it's not powder, it's actually molten metal fused together properly. And it just makes it more robust and more suitable for harsh environments, industrial environments, if it's going to be installed outside. And it took a very long time to get to this point, but we are in production mode. We are ready to produce it. We are done with research and development. We have data that shows the efficiency. The efficiency gets much better. The more heat you apply to it, the more it can withstand heat, the more efficient it becomes. And avoiding these two limitations, the powder metallurgy, and the absence of solder, allow us to expose it to very harsh environment where we can generate enough energy to do that. So automotive, greenhouses, and industrial waste. And of course, as a auxiliary system to solar. So it will complement solar, especially in off-grid situations. What are the other applications? Remote sensing. If you have a camera installed on top of the mountain and you want to power it without sending somebody up there to change your battery, one of these devices is sufficient enough. One side is shielded from the elements of the weather, and the other one is exposed, connected to a capacitor bank. As long as there is weather fluctuations, and you can depend on that in Vancouver, I think, you will always keep charging this capacitor bank and it will always stay full. I have a LED strip in my garage that's been lit for the past 3 months, nonstop. I did not charge anything. So I have a demo unit here. It is very sensitive to be operated even with the heat from your hand. If I can demonstrate it, hopefully it will work. So it doesn't, please don't impress me. Yeah, here we go. I don't know if you can see this green light here, small. This is just from the heat from my hand. Once I remove the heat source, it starts dimming, and we are ready for production. This device, the manufacturing method really is what made this possible. So this is not a novelty. This is something that can be produced in the thousands. We can produce this in different shapes depending on the application. So the next step is to produce a 1,000 or 1 kilowatt unit. And also we are, I think we open for suggestions, or if there is an application, we can actually tailor it in terms of materials and purity to make it suitable for this application. Once I was done with the development phase and I started looking for raw materials, I was shocked by how difficult it is to get the raw materials. And I started looking for a partner. And the first thing that popped in front of me was first Tellurium. I reached out to Ty and gave him a proposal, and this is how we started our relationship. And now I'm pleased to show you this device. If you're interested, if you want to measure it, if you want to know more about it, please reach out to me. And I love talking about the material science. And an ice cube? Yeah, you can, yeah, give me an ice cube. I mean, this is just to demonstrate that you have a spoon? Yeah, a gyro spoon. Yeah, it was funny because yesterday I was talking to Ty, and people think that energy always has to be hot, but if this thing is covered with snow, it will generate even more electricity. And I don't know if you can see that. I don't want to make a mess, but yeah, hopefully it will stay there. Wow.
Well, the blue light came on.
Yeah, so yeah, it generates more actually. Yeah, so feel free to play with it. Please don't break it. But yeah, this is purely based on material and how they interact with each other. We just made it more robust, easy to manufacture, and suited for harsh environments, so it can actually become an industrially viable and economically viable solution along with solar. Thank you very much.
Don Freshy met with Michael yesterday, and Michael gave the demonstration on this, and it was like, Don Freshy, I don't want to misquote you, things that you guys have nailed it or hit it out of the park or life changing or something. So if you wouldn't mind just come up and give what your thoughts are on this as a professional, I appreciate that because it means more than myself.
Yeah, being exposed in the world to different thermoelectrics, we've done thermal photovoltaics with gallium and timonide. As Michael mentioned, everything has to do with the solder and the way those ingredients are put together, those metals. And this is a game changer because all the ones for the past 35 years in semiconductors, I haven't seen anything like this perform. Again, being dealt with thermoelectrics cracking, semiconductors cracking, the way he put those materials together, and these are materials we produce in Trail. Like everything he uses in here, we manufacture. And the beauty with this device is we can do it on a low end. We can offer a lower quality pure metal, or we can go to a really high purity metal. So the way it's worked is when they first started solar and other panels, like First Solar, they started with low grade. It was all 99.99, 4/9 pure. Now everybody wants 6/9 and 7/9 purity because efficiencies quadruple. So imagine this device powering an iPhone. If we put in 7 nines material of, the materials in there, tellurium, antimony, other things, that device could shrink to tiny and yet power, half a city block. So that's why no one right now, like I'm serious, when Ty says you want to take a picture, you want to get yourself with a picture of this right now, because I'm certainly going to get a picture. And I mean, it's obviously good for the whole industry, mining, our company, everybody going forward. So it's a game changer. Yeah.